So we're in the woods again, and we have a large hardwood that's been blown over, the red oak, and I've cut it up into pieces to split it into firewood. Most of my projects start out with a task I have to do, and then I end up trying to find an easier way to accomplish that task. So I went to the hardware store, bought a log splitter, manual log splitter like this, and began to split this wood. And it split quite easily because it was a red oak. But I began to think about buying a hydraulic log splitter or some type of log splitter maybe I could hook up to the back of my tractor to make this task a little bit easier. So this is not all the wood that I split. You can see some other pieces in the back there. It turned out I filled this trailer up, and I don't like to waste good wood that's blown over. I didn't cut that tree down. It blew over on its own in the storm or something. And I began to think about a hydraulic log splitter, but I didn't want to spend a lot of money on a log splitter. So I began to research the internet and YouTube, and I came up with this idea of making a cone splitter. Now, they don't sell these in the United States. They used to sell them, but you can buy the components to build this yourself from overseas. And this actually came from Poland, the cone part and the bearing carrier part. And I fabricated the rest of it, and bought a 3-point hitch that came from online. So a side view of this shows the cone, and it's a 3-piece cone here. There's a tip that's the darker piece, and then there's a center piece, and then there's this expansion piece on the end of it. And everything else, the bearing carrier comes with it as a kit. Everything else I fabricated except for the 3-point hitch. But I could have done that as well. It was easier to buy it. Here's the other side view. Notice I bolted it to the standoff, which I fabricated. And then there's a plate underneath the bottom, which we'll talk about a little bit later, underneath the cone, and what its purpose is. Here's a back view of the project, and notice I have some treated lumber there where it sits on the ground, 3-point hitch, and underneath that plastic is where the shaft spline that goes to the PTO connects up to the tractor. So I went online and I found this company called Forsplit, and they're from Poland, and it appears that over there they use a lot of wood for heating, and they sell several configurations and about 3 different sizes here. You can see light, strong, and super strong. I bought the super strong, and you can use several different things to turn the shaft, electric motor or some other type of prime mover, and of course the tractor, which is what I'm using. And you can go in there and configure whatever you want here, many different configurations to choose from. So I chose the super strong kit, and it came with a 170 millimeter screw, which is the part that goes the largest here, and then I added that other piece to it. Notice it has a cone over here to a tip to the left that's replaceable. This is what I call the a holder for the bearings. I call it a bearing carrier, but on either end of the shaft there's bearings in this carrier, and then you can see the spline part that goes to the PTO shaft of the tractor, and the other end goes to the actual cone part, and then there's a base down there, flat base, that you can bolt up to your other stuff. This is an additional piece I bought that goes at the end, and it just kind of flares out even more to help split that log as it pulls in. So I went online and ordered this. Not very expensive, a couple $100, and it came in, and very heavy. That shaft is probably, I don't know, at least an inch or more in diameter. It is heavy, solid steel, very good quality, extremely good quality. Problem is they sent me the wrong one. So they sent me the one that's used to be used with a pulley and a belt system, and I needed the one that went with the tractor. PTO. So I called them up, and they were very quick to, well, I actually emailed them, and they were very quick to respond to me. And they said, okay, well, we'll just send you the new shaft if you're able to replace it. And I said, sure. So here is the old shaft. You can tell it's smooth on both ends. And the end that's closest to us is the one where the pulley attaches. Um, and the other end is where the screw attachment attaches. And you can tell these are very large bearings, and they're held in by circlips. And because it was new, this was very easy to press out. There was no rust or any issues in getting these out and replacing the shaft. But I had to get the new shaft in, and I don't have a vertical press, so I used my trailer and a bottle jack, and was able to gently press that shaft into those bearings, and it worked very well. Again, this was brand new equipment, so there was no impediment to no rust impediment or anything of that nature to prevent pushing that new shaft in. So now we're going to move into the fabrication process. I bought a 3-point hitch off the internet, and it wasn't very expensive either, maybe $100 or something like that. Came in, even came with the pins and everything that you see here that I fitted up to the back of the tractor just for a test fit. And then I began to just construct things. I didn't work off any plans. I didn't draw up any plans. I just kind of had an idea in my head. And based on things I saw on YouTube and on the internet, I just began to formulate, what does this need to look like? What kind of clearances do I need? Distances do I need? How long of a PTO shaft do I need? And I just began to, cut pieces and start to work with it very carefully. And here is, this hasn't been welded up yet, but I've built basically the structure for support that will sit on the ground. Later on I put some wood underneath it, so it wasn't direct metal to ground or anything like that. To cut the metal, I bought this product and was very impressed with it. It's a chop saw, but it's not a abrasive chop saw. That's a carbide tip blade right there. I think it's 14 inches in diameter, and it cuts through steel like you wouldn't believe. And I cut some very heavy steel here. Some of this stuff was approaching, I don't know, 5/8 or something like that on the tube steel, but it's just a chop saw, but you can adjust the angle that you want to cut. So I'm cutting some angle iron here. Here's some channel I cut through, and when it cuts, it produces little chips. And I don't know if you can tell right here up against the end of the saw, I put some magnets, very strong magnets out of magnetrons from microwave where the magnetron had quit working, and they worked very well to contain those chips of metal as they're cut. And then to weld this up, I just used a entry-level welder that you get at the big box stores, and they say that this is good for a 1/4-inch steel, but I can tell you I have welded a lot heavier steel than that with this, and actually had to put a new circuit breaker in my panel box to prevent tripping that out and get a much larger extension cord. So here we're advancing into the project, and I've done a lot of work. It's upside down right now with the plate on the bottom, and a lot of welding, bracing here. I only wanted to build this one time in my lifetime. Didn't want to have to fix it later on, so I spent a lot of time, put a lot of extra effort into support and rigidity, making this thing strong. I don't weld normally, but I did teach myself to weld good enough to get me by on my projects. And you see a lot of bracing here, probably overkill, way overkill, but that's just the way I operate. Here it is flipped over. Notice it's got some sharp edges on the corners, and I cut those off later, but it's going to take a lot of form, a lot of shape. That's our working surface there. That's where we're going to put the log up there, and later on you'll see where the cone splitter will be added. But it's really taking a lot of shapes. Not very heavy, but at this point. So here's the out of the box with the shaft replaced, without the cone on it, from 4-split. And to the right, I uh, built these standoffs that work very well. And the holes line up with the holes there on that bearing carrier. Here we're just sizing things up. Nothing welded here yet. I'm just kind of getting an idea. Is this going to work the way I want it to work? Is the cone high enough off the table? I'm just kind of feeling things through. Here's the back view. I'm figuring out how far do I need to push this in on that table, versus where the 3-point hitch component is. It's going to be clearance for the log as it splits it. So I'm really just kind of feeling my way through this. And then we make some decisions and we start welding. And we're welding the base here. And notice I did not weld the bearing carrier on there because at some point I may need to take that thing down and replace those bearings and press them out. So this thing, I built that to be taken off. And here's a side view of it. And notice the corners have been cut off and ground down so they're smooth. And this becomes an immovable object, just like the tractor, when it's sitting on the ground. So you don't want to hit that with your shin or legs. That would hurt. So to preserve the metal, I've used this product in the past called Por 15. And it's really a 3-step process. You have to clean and degrease the metal. And the metal prep goes on, and it basically etches the metal. And you end up with a zinc phosphate coating on the metal. And then you paint over it with this this Por 15 paint. And it's a rust inhibitor. Used very commonly in automotive restorations on the frames or any parts of the car you don't want any rust on. So you can see here everything's welded up and all of the welds have been cleaned up. And we're beginning to set that plate, which we'll talk about in a minute. But you can see there's a white residue around the metal. So it's been completely degreased and washed and coated with metal etch and rinsed off. But it leaves this white residue, and that's very key to the adhesion of the Por 15 paint that prevents rust. And I've used it on a lot of different things, cars and things, welds and such. So here we are, we're setting that plate. Now what is the plate for? That plate serves to prevent the log from spinning underneath the cone as the cone draws it in. So the cone is just a big screw, and it's screwing into the wood, and it's going to bring that log in there. And you don't want it to spin underneath the cone because it'll jam it up and cause some damage. So that's what that plate's for. So we set that, welded up. Notice that there's a piece of angle iron on the back side. As this thing turns, it's turning clockwise, it's going to draw that piece of wood or the log in, and it's going to drag it against that plate. So the other side of the plate is smooth. This side of the plate doesn't drag. This doesn't drag the log on this side, so there's no impediment. Here we're looking straight into the cone. You can see that piece of metal there that prevents the cone, from the log from spinning underneath it and causing damage. And that was ForSplit actually sold that piece, but I've fabricated my own to use here. And then here's a view to the side where the support is there, and a lot of stress on that plate, so I didn't want just a weld right there on the bottom. But you can tell that the plate is contoured to the cone. And if you ever have to remove the cone itself, you really have to remove the whole bearing carrier. So the bolts here you see allow that. Now here's the other side where the log will actually slide on the plate as the cone pulls it in. So it's like a big screw, just progressively gets larger, and as it pulls it in, it's going to split that log at the same time. So now we're going to go into a video demonstration of this in operation. So here you see we're attached to the tractor on PTO shaft, and I bought that and custom cut its length to what I needed. So we're putting the log that's already been somewhat split, and I pushed it on. You don't have to push it too hard. Once that screw grabs it, it pulls it right through. So I'm not pushing on anything here. And that additional piece I bought makes sure it clears the bearing carrier and everything else past that. So it really doesn't pull it much further than that, because it loses, I guess, some tension there on the wood. Very little manipulation of the log as it's being pulled in. And of course you have to be careful with equipment at all times. And one thing I want to add to this is an engine kill switch. Not just a PTO kill switch, but I want an engine kill switch, which in my opinion is a faster stop. Okay? A much faster stop. The main thing I like about this is it was not very expensive. I think I've got maybe $1,200 in the entire project, and there's not much to break to this. You just keep it covered out of the weather. There's no hydraulics, there's no engine, anything of that nature. The only thing that might go wrong, or it might replace, is the bearings. Um, but I did buy an extra tip for it. You can buy the tips; they're not very expensive. The little black tip on the end. But that's a project that I came up with as a log splitter, and I may eventually get a hydraulic log splitter as well. And I just like things. But I expect this to serve my purposes for many years to come with little trouble.